the equation here, p minus 2x squared plus 8x plus p plus 4 equals 0, where p is a constant, has no real roots. Okay, so what this means here is that if you can use a quadratic formula, the b squared minus 4ac will give you a negative result, meaning you can't get any solutions. So you get imaginary results. And when that's the case, this means that our solution here was less than 0, meaning you cannot solve it. So that's what we have to say straight off the bat. If it said has one real root, means it's repeated, so you get exactly 0. If it's greater than 0, this means you have two solutions, like a normal quadratic. That's how it works. Now let's have a look. A, show that p satisfies p squared plus 2p minus 24 greater than 0. Now what I do here is I look over here and using the general quadratic formula, which is ax squared plus bx plus c, I let a equal p minus 2, b equals 8, and c equals p plus 4. Now I'm just going to go ahead and plug this into the discriminant equation. So you got 8 squared, which is 64, you got 4 already, and ac is just p minus 2, p plus 4. Okay, not bad. Now just expanding this and then just do some general maths. You got p times p is p squared, p and 4 is 4p, and you got minus 2p, so minus 2p and plus 4p gives us a plus 2p, and you got minus 2 times 4 is minus 8. Now you could expand this, but what I did is that I just divided everything by 4, because 4 and 64 both are divisible by 4. When you do that, that becomes 1 and that becomes 16. Now just opening up the bracket, and because you got a negative sign, inverse all the signs, so it'll be minus p squared, minus 2p, and plus 8. And now just rearrange it until you get the desired result. Easy stuff. Okay, part B now. So hence find the set of possible values of p. So guys, for this one, you just have to literally solve this quadratic equation. So you could factorize it, complete square, or use a formula. I just use a formula because if I have a calculator, it's easy to do it. So anyway, using the quadratic formula, I got p is 4 and minus 6. So now with these values, we need to see whether it's less than or greater or in between. Well, what I do is I draw a nice simple line across, like an inequality diagram. I put minus 6 on the left because it's smaller, and plus 4 on the right. And now I just test values between them. What I did here is that if you test the value, say between minus 6 and 4, like for example, I tested the value, let's say 0. When you plug in p is 0, what happens is that when you put 0, you get 0 squared plus 2 plus 0, which is nothing, equals minus 24. So minus 24 is not bigger than 0. Because minus 24 is not bigger than 0, this means that this interval in the middle is false. So we do not put a solution there. When you put a value bigger than 4, say, I don't know, 5, or let's say, just say 10 for the sake of it, you got 10 squared, which is 100, plus 20, which is, so for 120, minus 24 is, yep, it's definitely positive. It's definitely bigger than 0. So this side is true. Again, if you did a value on the left-hand side, like a bit less than minus 6, you also get a value which is bigger than 0. That's it. Whenever you find true statements, highlight it or underline it, and then say, okay, this region is true, so p can definitely be less than minus 6. This right side is true, so p can definitely be greater than 4. And that's our inequalities. All done. Okay. If you guys got any questions on each of this part, please let me know in the comment section. Otherwise, let's move on to number 5.